The other common eye defect is what we call hyperopia or farsightedness. In this case, the near point is too far. Uh, it is also called long-sightedness or hypermetropia. Hypermetropia. Now, farsightedness usually occurs to older people for most of us. But then there are some people who are farsighted from birth. Now, one thing to note, nearsightedness and farsightedness can be due to a lot of things. They can be due to physiological effects like the actual size of the eye, the actual size of the lens of the eye. But then they can be due to other things. And I'm not a biologist here to give you a more detailed answer. Okay, now in the case of farsightedness, objects that are too near are not going to be able to be seen clearly. For example, in this particular eye in this diagram, this eye can see objects only if they are further away than this point. Objects that are closer than this point, they are going to have their image formed behind the retina. So no matter what that eye does, the image is going to be formed behind the retina. To be able to see that image clearly, if we add a prescription glass, usually we need to add a prescription glass that's going to make these light rays converge faster. So we add a conversion lens. So to help the eye converge the light beams into the retina. Now, what this lens is going to do is going to take the object that's closer than the near point and project an image of that object further away than the near point of that particular person. In other words, if we call D near the distance separating the eye from the near point of the far-sighted eye. Now, when we wear contact lenses, then they are going to take an object at DO and form an image at DI that's equal to minus D near. Now, for normal people, normal vision eyes, we can see objects only that are further than 25 centimeters from the eye. So actually, D near for a normal person is 25 centimeters. So the prescription lens that we usually use is going to take objects that are at 25 centimeters from the eye and project them to the near point of the far-sighted person. So in our case, the object is going to be 25 centimeters. Again, we would like the image to be virtual, but further away from the object, virtual to keep it upright. So again, 1 over f lens is going to be 1 over 25 centimeters. That's our DO. That's the desired DO. Plus 1 over minus D near.